Math 3, Notes, Unit 9, Section 4. We're going to look at the graphs of logarithms. Okay. As we do with other functions, we get an idea of what the parent graph looks like first, and then from there that helps us in our graphing with other functions in that form. Okay. So we want to get an idea of what log base 2 of x looks like. So to do that, first we're going to fill out this table. We have y is equal to log base 2 of x. We're going to plug these values of x in and get y values for them. So if x is 1, then y is going to be log base 2 of 1. And if we change this out of exponential form, we get 2 to the power of y is equal to 1. So what's y going to equal? 2 to what power equals 1? 0. Okay. When x is 2, y is going to equal log base 2 of 2. We change that out of log form, we get 2 to the power of y is equal to 2. So from that equation, we can say y is going to equal 1. Why don't you finish filling out the table, okay? So these are the values that you want to end up getting. And so we're just, normally when we graph these, I'm not going to have you get this many points. But for the first time, we're going to get a series of points to graph them and get an idea of what the shape looks like. So go ahead and plot these points on the graph. See what shape emerges, okay? So you should get something like this. So what's our x-intercept? That is a 0.10. That's where it crosses the x-axis. Y-intercept? It doesn't appear that there is one. Well, at least from what we've graphed, but maybe there is one. So let's check. To find a y-intercept, you plug in 0 for x and solve for y. If we do that, we end up with y as log base 2 is 0. If you change that out of log form into exponential form, you get 2 to what power equals 0? Does that work? So we have no solution to this equation here, which confirms that there's no y-intercept. And the reason for that is, in this case, it's getting closer and closer to the y-axis, but never approaches it. And so we have this vertical asymptote along the y-axis. So it has an equation of x equals 0. So our domain for this starts at that vertical asymptote at 0 for x, and then goes to the right to infinity. And we don't include the 0 because it never hits it. And the range, it's going to hit all y values. So we'll go down to negative infinity, and it will slowly continue to increase as high as you want. So the range for all logarithmic functions will be negative infinity to infinity. So now we have some general shape here. The graphs that we're going to see are going to be in this shape. It may be translated right or left. If we translate it left or right, that vertical asymptote will also move with it. We also may see some that reflect. So if we reflect this, then it'll be decreasing. You'll never see one of these on the left-hand side of our vertical asymptote. So let's take a look at some examples now. So log base 3 of x minus 2. When graphing these, the most important part is, or the first thing you want to do is locate that vertical asymptote. And by default, it's the y-axis unless we've been translated left or right. And we do have a minus 2 here, so we need to interpret what that does to the parent graph. Which way does that translate? It's going to move down 2. But nothing moves it or translates it left or right. So the vertical asymptote is still going to be at the y-axis, which has what equation? X equals 0. Okay. From there, the next nice thing to find is the x-intercept. All these will have x-intercepts, and you can find an x-intercept by plugging in 0 for y. So if I want to solve for x in this equation, you have to get the logarithm alone. So that minus 2 is not part of the log, so I need to add that to both sides of the equation first. And once you get the logarithm by itself on one side of the equation, then you can change it out of log form into exponential form. And we write 3 squared is equal to x, or 9 is equal to x. And so that's our x-intercept, 9, 0. What's the y-intercept going to be? Will it ever hit the y-axis? No, because the y-axis right now has the vertical asymptote. So you can try it out, but you'll get no solution. And so you can also recognize from your picture that that you're not going to have a y-intercept. The only time you're going to have a y-intercept is when your vertical asymptote is to the left of the y-axis. We want to get a graph of this. We have one point, which is our x-intercept, but I want you to have at least 3 points to graph. With logarithms, it's easier to plug in y than it is for x. Most functions, it's easier to plug in x first and solve for y. But with logarithms, it's easier to pick a y value, plug it in, and then solve. And so if I want to pick an x value somewhere between 0 and 9, I want to think, should I pick a positive? Is it going to be below the x-axis, or will it be the graph be above? In this section right here. Here's my x-intercept. So is it moving up towards that x-intercept, or is it moving down to it? Based on what we saw here. Here, this is our general shape. It's moving up, right? And so if it hits the x-intercept at 9, it's going to be below the x-axis at these values. So I'm going to pick a negative y value. Let's try negative 1 for y. And solve for x. Again, when you solve, you want to get that logarithm by itself, so we're adding 2 to both sides. And when the logarithm's isolated, you want to change it to exponential form. So 3 to the power of 1 is equal to x. So we found out when x is 3, y is negative 1. And we have another point. Let's find one more. What would be a good option for y? Negative 3 or negative 2. I'm going to do negative 2, but if you want to try negative 3, you can. In this case, I get x is 1. So there's a third point at 1, negative 2. Okay, so there's a little sketch of our log function. Our domain, again, starts at 0, starts at that vertical asymptote, goes to infinity. Our range for all of these logarithmic functions goes from negative infinity to infinity. So I'm going to give you a couple-minute head start on this next one. Remember, locate the vertical asymptote first, then the x-intercepts. That's going to move it to the right. Yeah. Okay, I just wanted you to try starting without me. What you want to do first is go after that vertical asymptote. And what you're asking yourself is, it has this, by default, the vertical asymptote's at the y-axis. So you're just checking, did it move left or right at all? And in this case, that minus 2 is in the parentheses with the x, so it has moved to the right 2 units. And so the vertical asymptote should be at x equals 2. That's the first thing you wanted to get. Okay. From there, get the x-intercept, plug 0 in for y. It's already solved for the log. You can't add 2 to both sides this time because that 2 is in parentheses with the x. So it's in and part of that logarithm. So the only way to, the next step is to change it into exponential form. Anything to the power 0 is 1. And then add 2 to both sides. So we end up with an x-intercept at 3, 0. Okay. Question so far? That's how you want to start these. Any question on starting? So from there, we want to finish our graph. So I want you to get 2 more points. Again, it's easier to plug in y values than it is x. So you just got to think, well, here's my vertical asymptote. Nothing's going to be to the left of that. And so I'm pretty close to the edge already, so I'm going to need to find some points further away. And so do I want to plug in positive y values or negative y values? Will it be above the x-axis or below the x-axis over here in this region? Above, because it's increasing, right? So pick a positive y value, keep them small. Positive 1's a good one if you haven't done that, and positive 2 maybe, okay? I'm going to set y equal to 1 and go through the same kind of work here. I get x is 8 when y is 1. Five plus 2 is not 8? Oh, man. It should be 7. Okay. And then if I plug in y equals 2, chances are we're off of our grid. We could do that and get a third point way off the grid and put a point over there and graph it. Or we can get something closer. I could try -1. But if I do -1, I'm going to get a fraction. And I'm going to do that just to show you how that works. So here I get 5 to the -1 is x minus 2. And whenever your exponent's a negative, that's what introduces the fraction here. So this is going to be 1 over 5 is x minus 2. And I add 2 to both sides, and I get 2 plus 1/5 is x. So 2 plus 1/5, that's just a little bit more than 2. So I go to the right, a little bit more than 2, down 1. Just getting closer and closer to 2. So I got 3 points there now. Should I check for the y-intercept, or do we know for sure there's none? Here's the y-axis. This thing will never even get to the vertical asymptote. Will it reach the y-axis? No. So we don't need to check. We just write none. We definitely need to think through it. What would the domain be here? Starts at 2. It always starts at your vertical asymptote. So whatever number you're getting for your vertical asymptote should match the the first x value in your domain. And the range is always negative infinity to infinity. Now our next one, it says ln, but it's still a log. With what kind of base? E. What's different here, though, is it's got a negative out in front. And that negative is going to reflect this graph. So it's no longer going to increase, it's going to be decreasing. Okay? That plus 1 is going to move everything to the left one. And so again, start by finding your vertical asymptote. The vertical asymptote is going to be at -1, where x equals -1. Without even getting the graph, what would the domain be? -1 to positive infinity. What would the range be? Negative infinity to positive infinity. So that's kind of the relationship between these values. X-intercept, y-intercept, we got to find. Okay, so start next with the x-intercept. Plug in 0 for y. See what you end up with. Before we do though, will we have a y-intercept on this one? So our graph's going to get as close to -1 as it can. And so it's got to cross this y-axis somewhere. So yes, we will. But let's find the x-intercept first. This time we can't write none for the y-intercept though. We will have a y-intercept. So again, when you're solving for a natural log or any log, make sure the log is by itself. So that negative in front, we've got to get rid of the negative before we change it out of exponential form. We could do that by multiplying both sides by -1. Remember, it's base e. So when I change it into exponential form, I get e to the power of 0 is x plus 1. Anything to the power of 0 is 1. And then I subtract 1 and I get 0 is equal to x. So y is 0 and x is 0, so my x-intercept is 0, 0. What's the y-intercept going to be? Turns out the x-intercept and the y-intercept are both 0, 0. That's the only point that is on both the x-axis and the y-axis, okay? So we got 2 for 1 on that one. Okay. I need 2 more points for the graph. What would be another good point to plug in for y? -1, because this thing is decreasing now. So if I want to fill in some of the graph over here, I know it's going to be below the x-axis, so -1 would be a good choice. The first step, multiply both sides by negative. Change it out of this form. And we get e is equal to x plus 1. And if I solve for x, I get x is equal to e minus 1. So just remember this. E is roughly 2.7. Just like pi is roughly 3.14, right? E is roughly 2.7. And so if I have 2.7 minus 1, that's going to be about 1.7. So I have the point 1.7 comma -1. Okay, and it confirms that this thing is decreasing. find one more value. What do you guys want to plug in? -2? I plug in -2. Oh yeah, that's not 1.7. I was going. I was looking at the. I was looking at the vertical asymptote, not the not the y-axis. So 1.7 would be roughly here. So 2 is natural log of x plus 1. So e squared is equal to x plus 1. So x is going to be e squared minus 1. So if you have a calculator, feel free to type that in your calculator. Your scientific calculator should have a button with e on it. Or you could do 2.7 squared. So e squared minus 1 is going to be roughly 6.4.
She tried. Wait, what was it?
So 6.4 comma -2. It varies from calculator to calculator, but I can come and help you with yours. Well, let me get the start on the next one. All right, this last one, our vertical asymptote comes from this x plus 2 area here, because this is going to move it to the left 2. And so we're going to have x equals -2. Will we have a y-intercept? Yes, if your vertical asymptote is to the left of the y-axis, you will have that. This one, though, has a negative sign in front of the log, which is going to make this reflect. So it will be decreasing like the last one we looked at. Okay. So our domain is going to go from -2 to infinity. Our range is -infinity to infinity. But go ahead and find the x and the y-intercepts. Here. So for our x-intercept, what do you guys get? That's 6? Okay, so let's check. So if we plug in 0 for y, first step is to subtract 3 from both sides. Second step, multiply both sides by -1. Then at this stage, change it out of log form, put it into exponential. So we get 2 to the power of 3 is x plus 2. 2 to the power of 3 is 8. And so then when we subtract 2, we do get 6. So our x-intercept is at 6, 0. In this case, it's not our y-intercept, so we're going to have to find our y-intercept as well. For the y-intercept, we plug in x is 0. What did you guys get for that one? Had trouble finding it? Okay. So what's different about this one is we don't need to solve for y because it's already solved for y. we just need to evaluate. So we're not going to be adding something to both sides of the equation or anything like that. We're just going to figure out what number this is. So it's going to be 3 minus some log. And so we need to figure out what the log value is. What is log base 2 of 2? So that's asking the question, 2 to what power is 2? 1. So that log has a value of 1, so we're going to get y is 3 minus 1. So my y-intercept is going to be 2. And that gives us the second point. And then I want to find a third point for my graph. What would be a good value for y to plug in? 2, we already know. We have that one. That's our y-intercept. So try plugging in a 1. So when we plug in a 1, we're going to get 2 squared is equal to x plus 2. So x is going to equal 2.